sustainable sanitation design, and it was really encouraging this morning to see that the research and engineering is coming towards the user. The engineering, the research is not standing alone any longer. And sustainable sanitation design, we started out looking at the sanitation sector from an industrial design and service design perspective. And that's really where we believe that the scale-up can take place, because we have to create businesses, we have to create value addition, we have to create products that people really want to use every single day, because this is the best example of a repeat business. And so sustainable sanitation design started out as kind of with a different focus. We started out thinking about how to scale up and not just to be part of a community of pilot projects. My name is Karsten Gjefle. I'm the director of SuSan Design and founder. My co-founder is an industrial designer called Øyvind, and we started the work in 2007, 2008 with an analysis phase, and then we established SuSan Design in 2009. Our mission is to deliver innovative solutions and concepts and products that can link into value creation and full value chains from home to farm. And so we would like these structures to be put in place in urban communities based on the quality that they deliver in terms of service and in terms of dignity. So we believe that the sanitation infrastructure that is going to be put in place in the future will have to be based on value creation, because there's not enough subsidy dollars or euros or rands to actually handle the urban poor. So there has to be some income generation coming from the nutrients and savings based on less water uses, as it was said this morning. It's not the water-based system that is the future, it's the waterless or the next or close to waterless systems that are going to be the future systems. And that is how we have designed this structure, and that is how we would like to preserve the nutrients in the volumes that come into our toilets. And our work, as I mentioned, started in 2007, but our organization started in 2009, and we were fortunate to be part of the grant process of the Gates Foundation with the Grand Challenge exploration, and that made it possible for us to actually test the ammonia treatment methodology in a larger scale in Kampala, Uganda. But next to that, we have looked at how urine can become a value for either the flower industry or commercial farmers, and making sure that the fertilizer value of that urine comes back to the communities, comes back to the entrepreneurs that run urban public units or run the logistical systems or have a workplace in the treatment units. And in order to support that focus on urine, since that is the pure side of our human excreta, we have put a lot of focus on urinals. So urinals for women we have designed and tested in Nairobi. You will see them later, and that will bring larger volumes of clean urine into our system. It's easier for a man to run out and pee than for a woman, so it's about time that we designed urinals for women that can be in an ordinary home in an urban city in Africa. Yes. So this is part of the work we've done, and based on the partnership, this is part of our partnership. We've been working closely with the Swedish University of Agricultural Sciences, with an NGO based in Uganda called SSWARS, sustainable sanitation, water renewable systems. The Gates Foundation, of course, Makerere University and the GIZ has supported our work. And also we have worked closely with agricultural partners. So the National Agricultural Research Organization in Uganda has tested our material that we produced in our secondary treatment unit with good results. You will see some pictures later. And we also work with an organization, a Norwegian agricultural organization, in terms of looking at how can we organize fertilizer shipment and fertilizer use, safe fertilizer use in ordinary commercial farming that takes place around the cities that we look upon as production centers for natural fertilizer. So this is the simplified business model of sustainable sanitation design. Our toilets and urinals. Our toilets, we have not finished the development of them. We haven't been able to do that, but we have looked upon different models and we can integrate many of the existing types of either pits or septic tanks into the treatment units that we have tried. But it's the treatment that is the focus today, because that is the basis for delivering that value creation, that we have a safe product. One of the key principles when we started out was, if we're going to sell something, it has to be safe. And urine can be safe, and it is safe when it exits our body. But if it is contaminated by fecal matter, then of course it has to be stored and handled in a proper way. And fecal matter is automatically pathogen rich, so we have to deal with it in a robust and good way, making sure that it is pathogen free when we deliver it to farmers or the flower industry or whoever is going to use it or buy it. And we scrambled a bit in the beginning because we were thinking that, okay, we should be able to compost it, and we started looking at the figures. If we were going to compost fecal matter from 1 million people in Kampala, then we would never be able to find the biomass that is needed to actually do it. So we needed something different, something robust, something that could actually be scaled up. And that's how we started the cooperation with the Swedish University of Agricultural Sciences. They have been working on how nitrogen can kickstart a biological process and make fecal matter a safe product that can be used by farmers. So we have taken on board that research and looked upon it from an industrial design point of view, and it looked upon it from a logistical point of view. How can we actually transform these volumes into usable and valuable, safe, human waste-based fertilizer? So that was our challenge, and that's what we tried to set up in Kampala, starting for about a year ago, and now we have kind of finalized that first treatment unit. So during a 45-day process time, we assure that it is what they call log 4 reduction. So there's a 99. So it's a 99.99% reduction of pathogens during those 45 days. I can go back a bit. So, and one of the great advantages with this structure is that we can handle a 50-liter container, we can handle a 5,000-liter container, we can handle things from dry toilets, we can handle it from septic tanks, we can handle it from pit latrine emptying services. And in Uganda, in Kampala, we took volumes from all these 3 different types of toilets, which represent about 98% of fecal sludge in Africa. So it's a decent amount of sludge out there to be handled. And we during these 45 days, we tested with two separate teams, the Swedish Agricultural University team and the National Agricultural Research Organization team in Uganda. Both tested the pathogen content of it after our process and found it pathogen-free and usable for, and well within the limits that are designed or done by WHO. So these 45 days is a relatively quick turnaround in terms of bringing it to safe reuse. And one of the next steps would be how to optimize the structure, either to make it happen quicker or just cheaper. And we're still well within the 5 cents of the Gates Foundation, so we are on the right track. And pathogen-wise, we're definitely on the right track. And we also are, we have used the material in agricultural lands in a field testing, science-based field testing with in Uganda that has given good results. There is a more technical presentation later today at 14:25. I think it is in this room. So if you're looking for the nitty-gritty from the scientists themselves, they will be able to provide you with that side. Our function is to bring the science into practical use and make sure that what the science has told us it can deliver is actually delivered on every single at every single treatment unit. So this was just one of the trucks that came to us delivering nutrients. That's how we like to call it. And this was in Kampala. Just we had a 2-hectare field or farm, 20 kilometers or so out of Kampala, where we set up our secondary treatment unit. And in addition to the ammonia-based or ammonia treatments, we also tested composting, and we're also looking into how biochar can function and be brought into the sludge volume to increase the fertilizer value, increase the soil improvement value of the sludge. So these are just pictures from the units and from some of the work that was done in order to set up the secondary treatment unit that is modeled to serve about the volumes coming from about 2,000 people. And the next phase will then, of course, have to deal with somewhere between 20 to 30,000 people for one unit. This is some of the handling. You can see that there's some urine coming in. There's different size containers of fecal sludge coming in, and we have the flexibility to handle small or large volumes in the structure. So this is my co-founder. This is the co-founder, Eivind. Happy with his work, and you can see just it's an ordinary barrel that we used during the treatment process. So there's no high tech. We're completely off grid, and we can handle it without electricity or any other an energy input during the process. And during the process, of course, there are if you can call them milestones or checkpoints. We follow different parameters in order to make sure that the process is taking place correctly. We follow temperature, we follow how the volume evolves in terms of pH, etc. And we have certain routines to make sure that the process is actually taking place in the way we assumed it was going to do based on the research, and also how the experience that we're starting to develop. So that picture was actually from the lab in Kampala, where one of the SLU master students was working with us to do part of the testing. So toilets and urinals are very important for us, and that will be our next step, to look at how do toilets actually provide the service that is necessary, and how do the toilets function as the first step in this value chain. Toilets shouldn't function in any way, in any conceivable way. They should actually function within the logic of the logistical system that is necessary to handle the shit. Because if everything comes in all kinds of different ways, it's more costly to actually handle human waste or nutrients, that we like to say. So it's important for us as industrial designers and value chain thinkers to look at how do actually toilet units function as the first step in a logistical framework that should bring the nutrients all the way out to the field in a safe and good way. So this is one of the projects that one of the products that we've developed. It's a very simple solution that provides a lot of dignity and a lot of good nutrients from a community. A home urinal that can be used, that is designed by women with women in Kampala, and it can be placed in a home. It doesn't give any smell, and the jerry can be collected after a week or two whenever it is full, and that 10 or 20 liters can be brought into a system, making sure that flower industry can get their 100,000 liters a week if that sale is quality checked. So we are looking at how urinals can function and how value chains can function in an urban environment in Kampala or Nairobi. This testing was done in Nairobi, in an urban slum in Nairobi with families, and also in a school, just to see how do children react to a home urinal. So, and we got very, very good feedback both from women and from children. And one of the groups that we didn't pay sufficient amount of attention to when we designed this product that came out very favorable was a lot of in urban slums. A lot of people are actually either bedridden or have difficulty of moving around, different types of handicaps. And when they suddenly had a urinal in their home, that was a great relief to them as well. And for women who don't have to go out at nights, taking either risk or just being uncomfortable being outside at night, it was also a great relief in terms of the product. Very simple, but it suits the logistical and economic framework of our value chain thinking. And when we did the market research in Kampala, one of the industries that could use urine was the flower industry. But they need good volumes. They need very high volumes in order for them to be able to replace their artificial fertilizer need. So in order for us to scale up, we have to work together with that type of users. And that's how we can provide sanitation services to urban poor for a lower cost and a much higher quality than it would be without this value creation thinking. The agricultural aspect. So the 26 tons that was produced during this test phase, much of it was used in an agricultural test that was done on maize, and it has just been finalized. We haven't received the final report yet, but the draft report indicates that the root structure was much better. The plant size was higher. The leaf size was bigger, but they didn't indicate a significant output in terms of yield increase of the maize itself. And this is something that we found quite surprising, because because we thought that we were giving the right balance between phosphorus and nitrogen. But during the testing phase, in order for the scientists to do this accurately, they took away a lot of the humus content in order to get a homogeneous material that they were going to provide to these 6 by 8 meter plots. We had 51 6 by 8 meter plots with maize that was planted. And in order for that, then a lot of the humus content was taken away. And now, looking at it from today's perspective, it could look like that the nitrogen gave a lot of plant growth and sturdiness to the maize, but it didn't actually receive the material that was necessary to actually create that extra yield increase. So there is some testing that we still need to do, but for us it has been great to be working with the agricultural community, because they are the ones that need to use our materials, and they are the ones who we need to convince as future buyers of our natural fertilizer. And I heard a figure the other day that when you compare the imports of agricultural fertilizer or industrial fertilizer to Uganda, we have the capacity as a sanitation group to provide 13 times the imports to Uganda if we manage our nutrients the right way. So that says a little bit about the potential for Uganda, and of course a similar type of potential will be for other places, other countries, in Africa in particular, but also in other countries, of course. So there is a huge potential for natural fertilizer. And in our way of thinking, we have been looking at, okay, there is an acceptance issue. How do we move forward on this acceptance issue? And what we have focused on is to make sure that we start with the plants that are high above ground, that are protected naturally by either, for instance, like maize or tree-hanging fruits and other types of. We don't start with lettuce and spinach. We start with the trees and the bananas and the cocoa production and the tea and the sugar and whatnot. All these things all these product types that don't have a direct contact with soil, and that's how we can build acceptance and promote natural fertilizer. So there are very many sectors that are very cash oriented. Commercial farmers are in those sectors. They know that they have to buy fertilizer to take care of their land, and it's our job to actually look at how can we provide that and bring that value creation back to the sanitation sector and make everybody incentivized to run sanitation systems. So, as you have heard, we are very focused on above ground systems. We are not a big fan of pit latrines, but if they're emptied, we're happy to take care of it. But we would prefer that the containers of fecal matter were actually easier to handle than from a pit latrine. And we don't think that pit latrine actually gives the quality service that people deserve. So there's a lot of improvement that can be done there. Schools, of course, today sanitation systems in schools, they break down after a year or two maximum because there's no handling. There's no value creation taking place from an urban school system or a rural school system for that matter. So we have to look at how can we bring farmers into that structure and make them incentivized to run school sanitation systems. How can we help them with knowledge and routines that can make school systems function in a better way? So the next phase will be scaling up in Kampala, with 3 to 5 units that are larger than the current 2,000. So we are assuming that it will be that the next size of our unit will be handling fecal sludge from 20 to 30,000 people. And then, of course, we will have to develop the agricultural tools in order to make sure that all of the nutrient value of fecal sludge and human excreta are brought back to the fields, not only the nitrogen side. So our challenge is to develop and help or participate in the development in value chains that go from home to farm, with better products, better services, incentives that go into the different links in this value chain. Thank you very much. It looks like I'm being kicked off.